All right, so let's go ahead and review lesson 8 by completing our study guide. You will be going through the play pause it video and watching. While you're watching this, you should be watching the video, and then make sure that you've completed the study guide on formative as well, just so you have your own record of this. All right, so number 1, select the graph that matches the function y equals 3x plus 7. So if it's 3x plus 7, one thing that's super important is that we can identify the plus 7, which is our initial value. So our initial value is that y-intercept. Okay, it's where our graph crosses the y-axis. So it should cross when it says 7. So let's go ahead and identify the ones or the graphs that do cross the y-axis at 7. So we have this one, this one, this one, but not this one. So this one's out already. Then we have the really important part is the rate of change as well. So the 3 is our rate of change. And one last thing that's very important is our x. Since it's just an x, that means that this equation has the form of y equals mx plus b, where m is our rate of change and b is our initial value. Since it has this form, that means that this is a linear equation or a linear function, either way. Since it's a linear function, when it's graphed, it should be a line. So yes, the top 2 graphs do pass through the point 7 on the y-axis, but they're not straight lines. Since they're not straight lines, then they cannot be our answers. So the one that should be your answer for number 1 is the bottom left. It is a straight line. It passes through the point 7 on the y-axis. And the last thing we need to check is the rate of change. So to get from one to the next, I'll just pick another point that I see it goes through. We do rise over run. So see how far it goes up, how far it goes over to get to the next point. So you go up from -2 to 7. So I rose 9 points and I went over 3 points. So rise over run is my rate of change. And my rise was 9, my run was 3. So my rate of change in this graph is 3, which is exactly what we wanted. So we just proved that it was completely matching the function we were given, y equals 3x plus 7. And that is it for the first question. Okay, let me just erase this so I have enough space for my next question. All right, and moving on to number 2. Select the function that matches the graph. Okay, so let's make it a little bit bigger so we can see a little bit clearer. So let's identify some main points. It is a line, so since it's a straight line, the equation needs to match the form of y equals mx plus b. So we can have our y, we can have our x. Okay, so it passes through the point 1 on our y-axis, so the initial value should be 1. Remember, this is your initial value, and this is your rate of change. All we need to do now, the only part we're missing now is our rate of change. So we'll just identify 2 points. We already have the initial value point. Let's just pick one more point. And remember that rate of change is rise over run. How far do you rise to get from one point to the next? So we rose up from -2 to +1. So that means we went up 3 over 1. Rise 3, run 1. So 3 divided by 1 is 3, meaning our rate of change is 3. So finally, we have our function, which is y equals 3x plus 1, and that is the third option. Okay, going ahead and moving on to question 3. Which table represents a linear function? All right, so for a table to represent a linear function, there needs to be a consistent change in y and a consistent change in x. So let's go ahead and you see what I'm talking about. So to get from one y value to the next in the first table, you add 2. But then to get from the next y value to the following, you add 3, and then you keep adding 3. The x's are always the same, where I have my add 1, but the y's are not. So there's no consistent rate of change, meaning that it varies. And if it varies, if the rate of change varies, it's not a linear function. So the first one is out. Then we go to the second one, do the same thing. I just like to start with the y's because that's usually where the issues come from. So then from 7 to 9, I add 2. 9 to 12, add 3. 12 to 15, add 3. Same exact issue. You have a varying rate of change. So it cannot be a linear function. Moving on to the bottom left, 7 to 11, add 4. 11 to 12, add 1. 12 to 13, add 1. Again, it varies. Cannot be a linear function. So that means our last one has to be our linear function, but let's prove it. So from 7 to 9, you add 2. 9 to 11, add 2. And 11 to 13, add 2. And just to make sure we're correct, 2 to 4, add 2, add 2, add 2. So yes, this one checks all the boxes we need. We have a consistent rate of change. Every time to get from one y value to the next, I add 2. To get from one x value to the next, I add 2 as well. Okay, so we had a consistent rate of change because all the y's had the same difference every time to get from one y value to the next, and all the x's had the same difference as well. So we had a consistent rate of change. That's why this one's correct. All right, so bottom right was your answer for number 3. Okay, moving to number 4. Which table does not represent a linear function? So this time we do want a rate of change that varies. Okay, so let's go ahead and go here. So negative 15 to 18, we add 3. From 18 to 20, you add 2. 20 to 21, add 1. Of course, this is varying. This is what they want. The rate of change is going to vary because here I'm just adding 1 every time. But this y is what's very important. So the one that doesn't represent a linear function is actually your first one because it has a varying rate of change. So let's just prove that we're correct or check that we're correct by looking at the other ones and making sure they are linear functions. Okay, so 8 to 5 minus 3. 5 to 2 minus 3. 2 to negative 1 minus 3. And then they have the same x values as the first one, so we know we're just adding 1 every time. So yes, this is linear. So it can't be our answer. The next one, the bottom left, 1 to 2, add 1. 2 to 3, add 1. 3 to 4, add 1. Consistent. Not. So it is linear, so it's not what we want. And finally, the bottom right, 5 to 10, add 5. 10 to 15, add 5. And 15 to 20, add 5. So this one's also linear. They wanted the one function or the one table that wasn't linear. So this was our non-linear function because it had a varying rate of change. And that is it for the first page. Let's go ahead and move on to number 5. Which graph shows a linear function? Remember, linear function in a graph means that it needs to be a straight line. All you need when you're looking for the graph again for a linear function is that it's a straight line. The only one that's a straight line is the top left. Okay, and that was all you needed for number 5. Moving on to number 6. Which graph does not show a linear function? Okay, so for it to not be a linear function, it does not need to be a straight line. It does not need to be a straight line. So the only one that's not a straight line is the top right. Okay, it's the top right. All right, and moving on to number 7. Which equation represents a linear function? This is when it gets really good, where it gets a little tricky. So for an equation to represent a linear function, it must be able to, it needs to satisfy something. So one thing is it should be able to be written in the form of y equals mx plus b. So we don't need any exponent for x. We need no exponent. Pretty much that's it. Okay, so let's go ahead and prove why some of these are not going to be linear functions. The first one, x equals 3. Remember, for something to be a function, or for a line to be a function, it needs to be able to pass a vertical line test when we graph it. So if I graph x equals 3, so if I have this as my 3 right here, and x equals 3, so no matter what it is, I'm going to have a line here where my x is always going to be 3. So I have this, and if I have this, there's no way that's going to pass the vertical line test, because literally I can just draw another line right there and it passes through every single point that's in that function. Okay, so that's not going to pass a vertical line test. It's literally a vertical line. So this first one is a vertical line, so it will not pass the vertical line test. Okay, so this is not the linear function we want at all. All right, the next one, y equals 16 over x. We're going to go back to our exponent rules for this one. So you can break apart this one if you want to figure out what I'm talking about. So y should be equal to 16 times 1 over x. I can just break it apart, because if I'm dividing by something, I can just multiply. If I'm dividing by something, that means I'm multiplying by the reciprocal. So if I am saying I'm multiplying by the reciprocal, then 1 over x is really x to the negative first power. So I really have y equals 16 x to the negative 1. Remember we talked about if it has the exponent, is not going to be a linear function. This one has that exponent, so it's not linear because of the exponent. Let's just say because it can't be written in y equals mx plus b, that form. All right, moving on to the third one, or the bottom right equation, y equals 3x squared plus 1. Again, you can easily figure out what this one is. So it has the exponent with the x. Since it has that, it cannot be written in the form of y equals mx plus b. The form it can be written in is y equals mx squared plus b. This is non-linear. We wanted the one that was linear. It's not going to be it. This is actually going to be a parabola. When you have the x value squared, it's going to give you a parabola, a curve. Something like that, kind of U-shaped. All right, and finally, we have y equals negative 3x plus 10. All right, so for this one, again, what we needed when we're looking at the equation is, can it be written in the form of y equals mx plus b? So y equals mx plus b. So we have our y, check. We have our m, which is our rate of change. Doesn't matter that it's negative, still linear. And then we have our x, just an x, no exponent, and our b, which is our initial value. So yes, this one is definitely a linear function. And we'll go ahead and move on to number 8. Which equation is not a linear function? All right, so you can easily tell which one is not. So remember we just said, well, it's not going to be a linear function if the x value has an exponent. So you can already tell the second one's going to be your nonlinear function, because it's going to be written in the form y equals mx squared plus b. That is non-linear. It's going to be a what again? A parabola. Okay, so we'll go ahead and prove why the others are linear functions. Y equals 17. You can actually write this in the form of y equals mx plus b. So you have your y already. Your mx, we don't have it. If you don't have the m or the x, that means that your slope was 0. So you have 0x plus your 17. So yes, this can be written in the form of y equals mx plus b. That is linear. Moving on to y equals 5x. The same thing as what we just did for the top left. For the bottom left, we can write this in the form of y equals mx plus b. Just because it doesn't have the plus something, it's just plus 0. So it must pass through 0 on the y-axis. All right, and then lastly, we have y equals negative 4x minus 12. Can it be written in the form of y equals mx plus b? Yes. You already have your y, you already have your m, you already have your x, and then your plus b could just be your negative 12. That's just keep, change, where you keep the first number the same or the first term the same, change subtraction to addition, which we did here, and change the second number to its opposite. So yes, it can be written in the form of y equals mx plus b. Okay, and then moving on to the last parts of our study guide. Number 9, determine whether each equation represents a linear or nonlinear function. Remember, we just talked about this. If it can be written in the form of y equals mx plus b, then it's linear. If it cannot, then it's nonlinear. Okay, so the first one, can that be written as in the form of y equals mx plus b? Yes, I can just add my 0. Definitely linear. What about the second one? I have y equals 4x minus 1. Yes, I can go ahead and identify all the main pieces. I have my y and my x. I have my m, which is my 4. And I have my b, which is negative 1. So yes, this is also linear. C, or the third one, y equals x squared plus 1. Nope, it is non-linear because my x value has the exponent with it. So it's actually going to give me a parabola, that curved U shape. It'll give me that if I graph it. So this is definitely non-linear. And then next I have y equals 0.75x plus 2. I have my m, which is my 0.75. I already have my x and my y. And then my b, which is my initial value, is just 2 here. So yes, this one's linear. And finally, y equals 0.5x cubed. Again, I have an exponent attached to my x, so that's going to be non-linear. Okay, and we'll move on to number 10. Which functions are linear, and select all that are correct. So now they're putting all of these things together. They're putting the tables with the equations, with the graphs. So you have to be able to prove, just like we did above, which ones are linear and how you know. Okay, so tables, you know if it has a consistent rate of change. So let's look how we get from our one x value to the next. You just add 1 every time. That's the rule. To get from one y value to the next, what's happening? Well, I'm just subtracting 5. That's consistent. That's linear. So this one's correct. Moving on to the next table, I have from -2 to -1. -1 is 0. 0 to 1, 1 to 2. I'm just adding 1 every time. Here, I add 0.75. Then I add 0.25 twice. but then I add 0.75 again. That is not consistent. It's a varying rate of change. Not our answer. Moving on, we have y equals 2x minus x squared. No. This one is definitely not going to be in the form of y equals mx plus b. Because, again, your leading x value, if you put them in the correct order, you need to have your y equals negative x squared plus 2x. We are not there yet, but definitely this will not give you a linear function. Okay, it cannot give you a line. Okay, because your x has an exponent. So no, this is not a linear function. All right, the next equation we have 5y equals 1/3 x, and I'll rewrite that here. Can this be written in the form of y equals mx plus b? That's the main question. So let's get our y on a side by itself. Let's divide both sides by 5. If we do that, then we'd have y equals 1/3 x divided by 5/1. So I'm really just doing 1/3 of x times 1/5, which is 1/15 x. So y equals 1/15 x. I can easily add on a plus 0. That will give me, or that will put it in the form of y equals mx plus b. My m will just be a fraction, and that's okay. As long as my x does not have an exponent, then I'm okay. Moving on, the graphs are one of the easiest things to see if it's linear or not. Is it a straight line? Is the bottom left a straight line? No, it's a straight up V. That is not a straight line. No, not a straight line. Okay, and then our bottom right, is it a straight line? Yes, it is. Straight line. And there you go. Moving on to number 11. Does the equation y equals negative 2x minus 3 represent a linear function? Remember, we said if we're talking about an equation, it needs to be able to be written in the form of y equals mx plus b, where b is our initial value and m is our rate of change. Do we have a rate of change here? Yes. Do we have an initial value here? Negative 3. Yes. Does it represent a linear function? Yes, it does, because it can be written in the form of y equals mx plus b. So it represents a linear function. And that is exactly what the second option represents. It says that for us. The graph of the equation is a line that can be represented with the equation y equals mx plus b. So the equation represents a linear function. And then we'll go ahead and move on to number 12. Carson's estimate for the cost of tiling his bathroom floor is $25 plus $5 per square foot. He says that he can model the cost with a linear function. Is Carson correct? Why or why not? So $5 is the fee he has to pay for tiling this bathroom. So that's an initial value, right? Y is going to be his total cost. Initial value, initial fee. And then he's going to be paying $5 per square foot. X could just be our number of feet squared. And then, of course, 5 is the price per foot. Look at that equation that we just created. Y equals 5x plus 5. So, can it be written in the form of y equals mx plus b? Yes, perfectly so. So, is Carson correct? Why or why not? Yes, he's correct. So, the ones that say no are out. He's correct because The cost can be modeled by blank, which is the form of y equals mx plus b. So we just need to look and match our equation up with the ones that they gave us the options for. The first one says y equals 5x plus 25, which is exactly what we said. So that's our answer. The bottom one says y equals 25x plus 5. This one really means that 25 is the cost per foot, and that is just not true. And 5 is the initial fee. No, they swapped them. So this one's not correct. Of course, this second one is our answer. Okay, and finally, our last one, number 13. Does the equation, and let me make this a little bit smaller so I can see everything. Does the equation y equals 9x squared plus 19 represent a linear function? With everything that we've done up until this moment, we should be able to look at this equation and say, nope, it's definitely not a linear function, because y equals 9x squared plus 19 cannot be written in the form of y equals mx plus b, which is a line. It's actually written in the form of y equals mx squared plus b. This is a parabola. Remember, we talked about that. When you have your x squared, that's going to give you that U shape, the parabola. So again, that is a parabola, which is not what we want. It's not linear. All right, so make a table of values in a graph, then use the drop down menu to justify your answer. Because the equation has a blank, it definitely has an exponent, so there we go. It has an exponent. It cannot be written in the form of y equals mx plus b. Here we go. When the equation is graphed, the rate of change between different pairs of coordinates on the graph is going to vary, and we're going to prove it now. Actually, I'll just go ahead and pause it. Well, pause what I'm doing. So if I have y equals 9x squared plus 19, if I go ahead and have my x's and y's, let me just have -2, -1, 0, 1, and 2. So if I say 9 times -2 squared plus 19. So I've got 9 times 4 plus 19. 9 times 4 is 36 plus 19 is going to give me 45. Oh, sorry, 55. That was dumb. 55. It's going to be the same thing for my bottom one, because -2 squared is the same thing as +2 squared. Okay, so let me go ahead and do my 9 times -1 squared plus 19. So I've got 9 times 1 plus 19. That's 9 plus 19, which is 28. Okay? And then finally, 9 times 0 squared plus 19 is just going to be 19. Okay, so I'm going to be going from 55 to 28. So to go from 55 to 28, let me just subtract over to the side. So I've got 27 minus 27. So, and then here, I'm going to be adding 27. That's already a varying rate of change. But let's continue. Then to go from 28 to 19, I subtract 9. To go from 19 to 28, I add 9. Every single thing is different. Everything. So all of the rates of change, it's too many rates of change. It should only be one. So the rate of change is going to vary. That's what number 3 in this question is talking about. All right, so the graph is a curve. So it's going to be a curve, okay? Yes, it's going to be a curve. Therefore, and when we say curve, it just means it's nonlinear. But remember, the proper name for a nonlinear function that has the x raised to the power of 2 is going to be our parabola. Okay? And I want to go ahead and show you this as well. Let me just go ahead and do this real quick. So if I have, let's say I got my 0, -1, -2, 1, 2, and let me just say, this one's 19, 28, 55. I obviously know this is not how I would actually graph it, but I just want to quickly show you what it looks like. Okay, so at 0, it'd be at 19, right? At -2, it'd be at 55. -1, 28, and then 1 at 28, and 2 at 55. Okay, I didn't even draw this on the scale. Let's just pretend it's right there. Okay, if I connect them as best I can with this little messed up graph I did, I've got my U shape. This is what I mean. Okay, so not only does the equation show it's not going to be a linear function because the x is raised to the second power, the table then proves it further because it has varying rates of change. And finally, the graph brings it home because it's going to give us that curve, that U shape, which is called our parabola. Okay, it's very important. And then finally, therefore, the equation represents a non-linear function. Non-linear. Okay, and that is all for lesson 8. We've learned to identify and we've learned to distinguish between linear and non-linear functions. Okay, you can always review this if you want to. Please make sure that you corrected everything on your study guide on formative if you haven't done so already. All right, thank you.